Okay, so stepping in after that. So where we're going to use this basically is we're going to talk about like how do we find all the zeros for a problem like this. Okay, so if I said, hey, find all the zeros for this, how do we do that? Where do we start this? So this is kind of an idea of like how to start this steps wise. One thing we definitely want to think about is that how can we use the graph to help us? So if we go ahead and graph the polynomial, realizing that the x-intercepts, and x-intercepts and zeros are so very closely related. So if we can look at the graph and we can see an x-intercept, that means we know one of the zeros. That's a good starting place. And so kind of like we saw on Tuesday, that if I can give you something to divide out, I can say, hey, this is something here, let's get rid of it, then that'll make it easier to find the other stuff. So that's usually the first thing you want to do is look at the graph and say, what can I see that's happening here that I can take advantage of? Okay, so look for an x-intercept on the graph. Once you think you have an x-intercept, you do want to check to see that it's actually right. You don't want to assume that it is the x, that is it, because especially since it's so easy to type something into your calculator wrong and get a completely wrong graph. You're looking at a graph that looks like it crosses the x-axis at 5 when it shouldn't because you typed something wrong. Okay, so you always want to verify that. So by doing the synthetic division to see if your graph matches the function. Okay, so you're going to use synthetic division to check it. And then once it is divided out, we're going to take what should be a smaller problem. Eventually, you want to get it down to a quadratic. So, if I take if I have an x cubed, like on this example here, and I take one of the x's out, I should be down to a quadratic. And once we get down to a quadratic, we know lots about solving quadratic equations, finding zeros for quadratic equations. So that's your end goal, is to take what you have and get it down to a quadratic. So if we have a cubic, we need to get rid of one of the zeros, and that'll give us down to a quadratic. If we had a quartic, like example 3 over here, we're going to have to find ways to get rid of 2 of the zeros to get it down to be a quadratic. Okay, so we want to be able to take that x to the 4th down to an x squared, and then solve it with all of our other tools. So, okay, so here's just kind of some tips on how to do that, the process. So let's go ahead and look at this problem, and you guys will need like either a graphing calculator or a graphing calculator app or Desmos open on your Mac. Okay. So if you need to get Desmos open, if you need to go grab up your graphing calculator, if you need to get your phone open because it's not open already, and get your graphing calculator app open, then please do that right now. And we're going to go ahead and graph this function here. Okay. So go ahead and type this into Desmos or whatever you're using to graph. So you guys should be seeing something like this from your graph. Try to get as close to a 10 by 10 window as I could, or a little better. Should be seeing something like that. Anybody not seeing their graph look like that? Tiger, is that what you're seeing? Matt, is that what you're seeing? Riley? Thanks, Victoria. So the fundamental theorem of algebra says that we should have how many answers to this graph? Okay. So, and zeros are the same thing, essentially the same things as what? X-intercepts, right? So we should be seeing 3 x-intercepts. So we don't, right? I only see 1, so maybe we just don't see enough of the graph, right? So we zoom out. That's why the apps are so nice, because you can just pinch out versus like trying to, if you're actually on your calculator, you have to do the changing the window, right? We'd see that graph, sure as heck doesn't look like it's going to come back down or come back up anytime soon, right? So it's shooting off all crazy. So we only see one answer. Well, what is that one answer? I mean, another thing that makes it so nice about these apps is I can just tap on it and it tells me what it is versus having to do some other steps in the calculator. So there's our one answer we can see, right? 3. So from the graph, we think that 3 is a 0, right? We do need to verify that, but we think that 3 is a 0. Right? So that's us interpreting, that information, right? So 3 should be a 0. So when I go to draw my little half box, I'm going to put 3 over here. Okay, remember that's a 0 we're being given, or a 0 we think we found. So it's not x plus 3 where we have to switch the sign. Right? We have the 0, so we do not switch the sign there. And then we always check for gaps when we're going to do synthetic division. You're going to do like 12 problems where there's no gaps in, and then all of a sudden there's going to be a problem with gaps in, and you're going to be like, crap, it's going to screw you up. Hey, you always need to check for gaps before you set up your box. So I see 3, 2, 1, 0, so I'm good to go. So 1, 2, -8, -21. Okay, run through the synthetic real fast. 3 times 1 is 3, plus 2 is 5, times 3 is 15, minus 8 is 7, times 3 is 21, plus -21 is 0. So we were supposed to be verifying if that number we grabbed off the graph is a 0, right? So is our 0 verified? Why is that, Ray?
Yes.
Or whose voice that was I just heard? Right, yeah, because the remainder is 0, right? So it's a 0 because it gives a 0, right? So, oops, check, right? So our first little piece of this problem is done, and we know we've done it right. Okay, that's really good, right? We've got that part. We know we have one of the answers out of the 3, and we know it's right. Sweet. Okay, you use that as a built-in check. Things are going well. Okay. So what do we do, right? Where are the other 2 coming from? Well, what do we have left? Okay, our remainder was 0, but our constant was 7, and our x squared. So what do we have left? Well, we have this, what I call the resulting polynomial. This x squared plus 5x plus 7. All right, we took the 3 out of the problem. We had this as our original function. We took 3 as an answer out of it, and now we're down to this. So you see how we've shrunk the problem? Okay? We don't have to solve a cubic equation anymore, because now we only have to find 2 more answers. So we're solving this quadratic equation. Or we want to solve a quadratic equation. It needs to be an equation. Okay? So what I say here as far as a step goes is you're going to write the resulting polynomial. And then you're going to set it equal to 0. Remember, you're trying to solve, you're trying to find the zeros, you're trying to find those x-intercepts. Right? And when we solve quadratics, we want the equation to be equal to 0. And then we think about, well, how do I solve a quadratic equation? So you guys should have a fair selection of tools here in order to solve this equation. So how do we solve quadratic equations?
Quadratic formula here.
Who's that? Is that Grant?
Yes.
Yeah, quadratic formula, right?
Yep.
That's definitely a tool. If you remember my analogy with the quadratic formula, it's the sledgehammer of the tools, right? It's the messy one that just kind of pounds the equation into submission. What else? How else can we solve quadratic equations? Sorry. Factoring, right on. Good old factoring. And then even within factoring, right? When you say factoring, then we have lots of other tools within factoring, right? So that's kind of a big word, right? And then you guys have one other main method of solving quadratic equations. If this was our equation, ooh, yeah, there you go, yeah, good, square roots. You're the first person to remember that and slash say that today, so just good job. So square roots, right? Get x by itself, and then square root, right? We just did that Tuesday. It's not like it's been forever since we did it. So yeah, square roots. So factoring and square roots are both like more precise tools. If the problem looks like this, I should use my square roots because that's fast. If the problem looks like this, then I should factor it, right? If it's not meeting any of those other things, then we smash it with the quadratic formula and say, bend to our will, give me your answers, okay? So as we look at this problem here that we have, what method should we be trying first? What method should we be trying first? I don't want some of you guys overthinking it and thinking past what I'm asking. The very first thing we look at this, we should try this first. It may not work, but we need to try it first. Okay? Yeah, factoring, and then more specifically, right, Katie, AC factoring, right? And so we look at that, right? And so our question is, let's try to factor this because factoring should be fast, right? There's a 1 there, we see, shortcut. So, our AC is 7. We need 7 to give us 5. So what are our factors of 7 that had to be 5? Oh, there, yeah, and Leisure, be a lovely thing to say in the public chat there. So if you want to copy and paste that so everybody else can read that. And that's exactly what I want you. I want you to say factoring and then think, right? So what I was saying, I didn't want you to overthink it. You need to be asking yourself, right? And you are asking yourself, and you're saying, I don't think this is going to work. And so then it is move on to the next step, right? Are there any factors of 7 that add to 5? No, right? And so we spend that 5 seconds, 10 seconds maybe to figure that out, that it doesn't work. Because if it had worked, it would save us so much time in comparison to doing the quadratic formula. Okay, if it had worked, we could do this problem very, very fast, and it would save us more time than we wasted by checking to see if it works. All right, does that make sense? So in the same way, if you can do square roots, you want to check to see if you can do square roots, because if you can, it's so much faster than doing the quadratic formula. Square roots also doesn't work here because of the multiple x's, but so. All right, we're out of options. We're out of the nice quick options, so we're down to smash it with the sledgehammer option. All right, so using the quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So if you need to write down this quadratic formula for yourself again, then you should do that. Notice that I'm not doing it. So Colby, what's our b value? Colby, what's our b value? Okay. Cole, what's our B value?
Five.
Okay. Kayla, what's our A value? Okay. Whoop. And Caleb, what's our C value? All right. So get all that stuff plugged in. Right. You should not be reaching for a calculator here. I mean, unless you need a little bit of arithmetic help. But there's no. This is definitely not something I want you guys giving me decimals back at. The very first time we did quadratic formula together, we did get decimal answers because we were looking at application problems where we were trying to figure out how long it took the ball to hit the ground or something like that. And we needed a number that made sense to us in real life, like 5.2 seconds makes sense to us. But whereas like 3 plus the square root of 7 seconds doesn't make sense to us. But this is not a time that we're trying to make sense of in our heads. This is us trying to get the exact answers to this problem. And exactness comes from those radicals. If it's the square root of 7, then it's the square root of 7. You know, the other day we looked at that graph and we were talking about the square root of 5. And I said, okay, well, let's turn that into 2.2 because when we want to go to graph it, trying to graph square root of 5 doesn't make sense to us. But so its value is close to 2.2, so that's where we go to try to graph it. When we write the answer, we say the square root of 5 is the answer. Okay? So this stuff should mainly be just stuff you're doing in your head. Okay? So of course that's negative 5 out there in the front, all over 2. Of course 5 squared is 25. And then just be really careful you're treating this right. You know, when I look at this, I see negative 4 times 1 times 7. Okay? That sign right there can either be a negative or it can be a minus, but it can't be both at the same time. It can be one or the other, but it can't be both. I'm going to call that a negative. So negative 4 times 1 times 7 is negative 28. So I'm going to go and write negative 28. And the next time I go to look at that, I'm going to call it a minus sign because it helps me there. Okay? But I'm not writing negative 28. Right? Or I'm not writing minus negative 28 because it's not a minus sign anymore because I turned it into a negative sign. Or if you want it to stay a minus sign, then you just look at the 4 and the 1 and the 7 without any signs. And so then it would say minus positive 28, which of course is just minus 28. Okay? I just don't want you guys doubling up that minus sign there. Okay? Which is just something I've seen, so that's the only reason I'm bringing it up. Of course, negative 5 plus or minus the square root of negative 3 over 2. Tiger, since I got that square root of negative 3 there, what's that mean about our answer?
Well, you have to, it's a plus or minus, so there'd be two answers, right?
Yeah, but I'm not talking about that part. The plus or minus is there. I'm talking about, it says the square root of negative 3. What's that mean about our answer?
Does that mean it's not possible?
It's not. It's possible, but it's not something else.
Okay, then I don't know.
Okay. Katie, what about that? That square root of negative 3, what's that mean?
It's imaginary.
Yeah, right. So I think what you're thinking about there, Tiger, is that it's not real, right? But we have imaginary numbers to use, right, that we created for the square roots of negatives. So we can take that negative out and bring it out as the I, but the 3, we can't break the 3 down, right? 3 doesn't go anywhere when it doesn't give us any pairs or anything when we sock it out. So we are just going to bring the I out there. So that'd be negative 5 plus or minus I radical 3 all over 2. And then you should be looking here, here, and here to see if this is reducible. But of course, those 3 numbers there don't share anything in common, so there's no reduction here. So there's our 2 other answers, right? We said we needed 3, but we had 1. There's our other 2. Kind of like what Tiger was saying with the plus minus. What the computer's going to want from you as far as writing your answers is going to say x equals negative 5 plus I radical 3 all over 2, comma, negative 5 minus I radical 3 all over 2, comma. And our first answer was 3, right? So that's what I want you guys to type in the answer box. And somebody last hour asked if it mattered what order you typed them in, because that was an issue at some point. The computer does not say anything about this time. You can type them in any order you want. So, oops, that's gonna happen. That's really a process that we're going to be kind of practicing today, guys. Is find a way to find one of the first, find a way to find that first zero, and then shrink the problem down to a quadratic, and then how do we solve a quadratic? So again, just how are we going to attack it? What can we use to do it? Okay. So they're kind of big problems. I mean, that's a lot of work. And there's lots of little places where you guys have to make decisions. Like, okay, it's saying this, that means I should go this way. Or, oh, it's this, I should go this way. Okay. So there's a lot of paths that you need to follow, and decisions you need to make that are going to lead you down certain ways versus others. So, okay. Anything here before we move on to the next little bit you guys want to poke at? Okay. All right, let's flip the page then. So finding that first zero. So, last time we saw on the graph, speaking of the graph, right, so we saw, we said earlier, right, there should be 3 answers, and but there was only 1 that we saw. Why now do we know we weren't seeing the other ones, right? Well, because they were imaginary. So that's why we only see 1 real x-intercept, and the other 2 don't show up on the graph. Okay, so that's the explanation for that. All right. So with the graph, when we looked at that one, we saw, oh, that's 3. That's super easy. And we clicked on the button as a 3, and it was all nice and pretty and everything like that. Sometimes the numbers aren't very pretty when you click on them, right? You get an answer and it says like 2.7824, and you're like, what am I supposed to divide by there, right? So this little tool here, and this is something you guys have all done, is to help us like kind of narrow things down, okay? Especially when the numbers aren't pretty, okay? Basically what the rational zeros theorem says is that, and I'm going to just point to this equation right here real quick, is that any rational zeros, any rational solutions to this equation, okay, any ones that actually exist, will come from a list of numbers that we generate by dividing all the factors of what they're calling A naught, which to us is just the constant term, divided by all the factors of A sub n, which to us is just the leading coefficient. Okay? If we take all the factors of this number divided by all the factors of this number, we'll generate a list of numbers, and then in any actual rational zero, remember rational means a fraction, will come from that list. So not everything on that list will be an answer, but anything that is an answer would be on that list. Okay? Any of you guys that were with me last semester or last year might remember that I talked about, like, I made a little story about like someone stole somebody's wallet, and we had to like find suspects and then narrow down the suspects, and this is kind of our way of doing that. We initially start off this problem and I say, hey, find all the answers or find all the zeros to this problem. Realistically, any number could be an answer, right? We have no idea what the answers are. Any number could be an answer. This is a way of saying, hey, well, now it's not just any number, but it's, one of these 10 numbers is the answer. And that's a lot easier to kind of deal with, say, okay, well, I can narrow it down from those 10 numbers rather than trying to narrow it down from, every number ever. So we're going to compare the constant term to the leading coefficient. So it's a little weird because it's like upside down. We start at the right end of the problem, not the left end. So it's a little weird, so just be careful about that. So what I'm going to do is I'm going to start by looking at just what's P. And I'm going to call P 2. Okay, I know it says -2 or it says -2 there. But the thing is, when we talk about factors, I say, what are the factors of 2? Well, 1 times 2, right? Well, but also -1 and -2. And if I say, what are the factors of -2? It's -1 and 2, or 1 and -2, right? I said the same numbers. So whether the thing I'm looking at is positive or negative, I still have to address all the positives and negatives there are. So I don't really need to worry about the sign. There's nothing wrong with writing -2 there. I'm being lazy, essentially. Okay. So all the factors of 2 are 1 and 2, or -1 and -2. All right, and all the factors of 3, Q is 3. Well, it's 1 and 3. But it could also be -1 and -3. So this is just the notation I use. So you can sit there and you can write 1 and -1 or 2 and -2. Write it out as a full list if you want. This is just how I do it. Okay, to write less. Now I want to write all these as fractions. So it's a ratio of P divided by Q. I'm going to take this number here that's in my P list. I'm going to divide it by all of the numbers that are in my Q list. Okay, so I'm taking 1 and dividing it by 1. I'm taking 1 and dividing it by 3. And I know I can reduce this, but I'm not going to do that right now. Okay, so I took 1 and divided by 1. I'm going to take 1 and I'm going to divide it by 3. So that number divided by everything that was in this list. Now I'm going to take the next number and do the same thing. I'm going to divide it by everything that's in this list. So 2 divided by 1 and then 2 divided by 3. Now, just like before, right, it's some mixture of positives or negatives that we don't know. So all of these could be positive or all of these could be negative. And if you guys were here with me, when we were doing this on a worksheet or something like that, this is how I would say, hey, just write it this way. That's the easiest way to write it. Because you guys are typing into a computer and it needs a little bit more specificity from you, it wants you to write every single number we see here. So 1 and -1, 1/3 and -1/3. So this is one of those rare cases where doing it on the computer is actually more work than not. Okay, so if it asks you to write list all the possible rational zeros, you have to write them all out like that. And I think I gave you guys 2 questions like that. And there you notice I went ahead and reduced them down. Okay, so I want you guys to go ahead and do the next part. So open up your Desmos, your graphing calculator, or whatever you're using here, and you're going to graph this function up here. And I want you to see which of these numbers shows up on your graph. Report back to me. Okay? Graph your function, and then see which of those numbers that's on that list we just generated shows up on the graph. I've got one answer here. Got 2 answers here. Piper, what are you seeing? Wesley, what are you seeing? Maddie, what are you seeing? Do we need to do a who's actually engaged in class check here real quick? What's going on, guys? Thanks, Alicia. Viper, Wesley, Maddie, good Caleb. Thanks, Riley. Thanks, BBO. I think I got about 1/3 of you guys paying attention. That's all I got. Get it? Yeah, okay. Ruth, I'm wondering if you typed something wrong because your answer shows up as way different than it should. So does your graph look like this, Ruth? So yeah, so double check your typing there. What are you using? Using an app or using a calculator? Okay, so just double check your typing, see if something looks off. Well, I mean that's an issue in itself, Maddie. If something's going wrong, you need to be speaking up and asking a question. So as we look in, of course, what's nice about Desmos or the apps is that we can zoom in and start to get a better idea. But looking at that list of numbers that we just generated, what numbers are we definitely not seeing? Like what types of numbers are we not seeing on our graph? No negatives, right? So we have this list of suspects and boom, all of those negative ones are gone. And what other types of numbers aren't we seeing on that graph? Yeah, no whole numbers, boom, boom. Now we're down to 2, right? I mean, these are only 2 that are left. So do we have 1/3 or do we have 2/3? And so we go back and say, well, we have the ability to tap on stuff, right? It's definitely not 3.4 because that's, it's not 1/3, 2/3, but what's 1/3 equal to as a decimal, guys? What's 1 divided by 3 equal to? Yeah, right? What's 2 divided by 3 equal to? If 1 divided by 3 is 3, 3, 3, 3, what's 2 divided by 3? 6, 6, 6, yeah, right. So it's definitely not 2/3, right? It's close, but it's not. So yeah, there's our 1/3. And I really say, I think you guys should know this. Like if for whatever reason you don't know what 1/3 is as a decimal, you really should, that it's 0.33 or, it's really 0.3 repeating. And the same way, 2/3 is 0.6 repeating. Now, if we're going to see 2/3 on something like this, it's going to say 0.667 because they are always going to round up that last thing. So you just got to be aware of that. It's 0.667 is usually what you see, even though it is 0.6 repeating. You should know 1/3. You should know 2/3. Of course, you better know 1/2. But 1/4, 2/4, 3/4, you should know those. And I would even say you guys should know your fifths: 1/5, 2/5, 3/5, 4/5, as like just common decimals. Okay? I'm not asking you guys to know what 5/6 is, okay, or 3/7, but you should know some common decimals, really up through your fifths. So you just recognize it. Oh yeah, there's 1/3. Because if you don't recognize it, it makes everything so much more difficult, guys. Okay? So 1/3's our guy, or lady, or whatever they feel like being at the moment. Okay. So we think 1/3 is, and then again, there's always that mystery, did we type something wrong, right? And so we need to go check, right? And so we have our function up there, and we glance at it and make sure there's no gaps, which there aren't. And so I bring down my 3, and I bring down my -13, and then I bring down my 10, and my -2, and I draw my half box, and then I'm going to bring that 1/3 over here. Okay, so we have done some division with. We're out of time. Oh, crap. All right, so we've done division with fractions before. Okay, we didn't have to do that initial little division thing, which is fine. Okay, so bring down the 3. 1/3 times 3 is 1. -3 times -13 plus 1 is -12. 1/3 of -12 is -4. You add those, you get 6. 1/3 of 6 is 2. You add those, you get 0. And so there's our verification. All right, it did work. Check. All right, 1/3 is right. We typed the graph in right. We generated our list right. Everything's working all awesome for us. Okay, so what's the quotient? What's left? There's our constant, there's our x squared. So I got 3x squared minus 12x plus 6. Since we are short on time, I'm just going to very quickly show you that we should be setting that equal to 0. And we should be trying to solve this. And if we go to try to factor it, you might notice that there is a GCF. So we can take that 3 out. Right? But taking the 3 out doesn't actually really help us because it's still a quadratic within the parentheses. There's nothing wrong with it. That doesn't really help us. And it turns out that that quadratic is not ACable either, okay? Because there's no factors of 2 that add to be -4. So we would go at the quadratic formula again. I don't think we're going to have time to finish this. I have that -4 there, so I'm using these numbers here. When you do the math in there, you get 16 minus 8, so that's 8. I would expect to see how you guys deal with that. So basically what I'm saying is that are you doing a SOC, or what are you doing? How are you figuring out what the square root of 8 is equal to? So SOCing that out and seeing that it's a pair of 2's and then a lonely 2. Right? That I'm kind of expecting to see how your work is progressing there. Not just that it all of a sudden just happens, and all of a sudden magically you've got this reduced radical that came out of nowhere. So, what did I do? And then last thing before I'll let you guys go, but those would reduce here. So you get 2 plus or minus, and then those other 2's turn into 1s. So you just end up with 2 plus or minus square root of 2. Then we did have our 1/3 from earlier. And we'll finish that last line up tomorrow.